All right, so we're going to be talking about permutations and combinations, but first we're going to do permutations. So before we do permutations, we need to go through what a factorial is. So for any positive integer n, the number n, and you have that exclamation point, and these are factorial, that's pronounced n factorial. Is going to be the equation n minus 1, and then be n minus 2, blah, 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 and you get 2 or 1. So what this means is that if I had 7 factorial, that is going to be 7, and then 7's my n. The next thing is one number less than that, so then 6. Then the next lowest number, 5, 4, 3, 2, 1. So this is good for you're talking about situations where we're counting down on something. Okay. And that's going to be 5,040. So this goes along with the fundamental counting principle. Oops, let me get rid of this part here for a second. So we have 5 runners are in a race. One of them will finish first, another will finish second, and then third, fourth, and fifth. How many orders can they finish? So we're assuming like they all have the same skill set here. So all the different ways they can finish would be, so whoever finishes first, there's 5 choices for that. After somebody finishes, that means there's 4 choices for who can finish second. After 2 people finish, there's only 3 choices about who can finish in the third place. Then after that, there's only 2 choices for the fourth place. And then after that, we only have 1 person left. So this is just 5 factorial. So when we have the situation where we count down like this, that's when we use factorials. So it still goes along with our fundamental counting principle. And just so we have that, 5 factorial is going to be 120. And just to put in here, just in case it does come up at some point, it's just sort of a rule that we kind of imposed on this is that if we have 0 factorial, we just say it equals 1. So permutation is another word for ordering. So when we're talking about different permutations, it's different orderings that we can have. When we count the number of permutations, we are counting the number of different ways that a group of items can be ordered. So if we have 5 people running a race, there is 120 ways to order all of those racers. Or when I had the, yeah, we'll go with that. I was gonna say there was another example we did, but I can't remember exactly what it was. So when we have n items and wish to choose r items that can be arranged in different orders, we calculate what is called a permutation. So this part about arranging in different orders is going to become a little more important when we start talking about combinations. So for example, sometimes we want to count the number of permutations of a part of a group. So let's say we have 10 runners in a race. We're going to have somebody finishes first place and gets a gold medal. We have somebody who's going to finish second place and get a silver medal, and we have somebody who finishes third place and wins a bronze medal. So I'm not asking how many different ways can people finish the race. I want to know how many different ways can the medals be awarded. So I'm looking at this. I'm just interested in the medals. So if I have 10 runners, there are 10 different people who can get that gold medal. After that gold medal is gotten, though, then we only have 9 people left over who can claim that silver medal. After those 9 people, after one of those 9 people has got that silver medal, now we only have 8 people left to take that bronze medal. So this is an example where I had 10 choices. There we go. 10 choices, and I'm going to choose only 3 of those choices. So this is where we have this thing where we talk about like 10 choose 3 or 12 choose 8, things like that. We're talking about how many am I actually taking. So I might have 10 choices, but I'm only interested in 3 of them. But that means that the different ways that I can get a medal is going to be 10 times 9 times 8, which is going to be 720. So I have 720 ways the medals can be awarded. Okay, so the permutation of R objects chosen from N. So in the last example, the 3 runners were chosen from a group of 10, then ordered in first, second, and third place. This is referred to a permutation of 3 items chosen from 10. So when we talk about this, we're going to have N and we're going to have R. So N is my total options. And it's always going to be the bigger number. And R is going to be the options chosen. So it's going to be the amount chosen. So in general, a permutation of R items chosen from N items is an ordering of R items. So in the last case, we were picking 3 items, so we ordered 3 items. It is obtained by using R items from a group of N items, then choosing a order of the N items. The number of permutations of R items chosen from N is going to be noted as this, NPR. So if I had chose 3 items chosen from 10, like we had previously, then we would write 10 PR or P3. Because this is my R, it's the amount that I'm choosing, and this is the total that I have, so that is my N. So remember, N is always like a sample size, so it's always going to be your total. So the number of permutations of R objects chosen from N, you could look at it like this, but really what we're going to do is this. We're going to take your 10, so the N, we're going to find a factorial of that. And then what we're going to do is we're going to take 10 minus R, which we said was 3, and find a factorial of that. So that's 10, 9, 8, 7, 6, 5, 4, 3. Well, actually, let me just go back one step before I do that. So that's going to be 10 factorial. 10 minus 3 is 7 factorial. So we're going to have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then we have 7, 6, 5, 4, 3, 2, 1. So the 7s, the 6, the 5s, the 4s, the 3s, the 2s, and the 1s, they all cancel. And I'm just left with 10 times 9 times 8 like I did previously. So this formula here is going to cause that same thing to happen. If I want to have 3 items out of 10, this is going to guarantee that I'm only left with 3 places to look at. So I'm ordering 3. So as an example, 5 lifeguards are available, 1 duty are available for one duty once available for duty one Saturday afternoon. I don't know why that was so hard. There are 3 lifeguard stations. How many ways can 3 lifeguards be chosen and ordered among the stations? So we have 5 lifeguards available, and what we want is only 3 of them. So we know I could just do 3 times 4 times, I'm sorry, 5 times 3 times, 5 times 4 times 3, but we're going to practice with the permutation. So remember, it's NPR, N factorial over N minus R. So we figure out what that is, factorial. So in our case, it's 5P3. So we have 5, but we're choosing 3. So we have 5 factorial on the top. And on the bottom, we're going to have 5 minus 3 factorial. No, it's going to work. Sorry, I thought something was off there for a second. That leaves me with 5 factorial over 2 factorial. So 5 times 4 times 3 times 2 times 1 divided by 2 times 1. So what that's just going to leave me with is going to leave me with the 5 times 4 times 3. So that is going to be 60, I believe. Yeah, 60. Another example of this, a corporation is going to have 5 days for training and needs to provide lunch for those days. A local restaurant has 12 different catered lunches to choose from. How many ways can 5 different lunches be chosen for the training? So I have 12 options to me, and I only want to choose 5 of them. And they have to be different lunches, so each time I choose a lunch, it's not available for my next choice for a lunch. So this is going to be 12p5. So that is going to be 12 factorial over 12 minus 5 factorial. So that is going to be 12 factorial. And then what we're going to have here is that it's going to be 7 factorial. So we don't have to write everything out, figure out what cancels. 12 factorial is 479,001,600. 7 factorial is going to be 5,040. There we go. Try and get this in my calculator. That means that in the end here, if I do this division, I am going to be left with 95,040. So I have oh my God, 95,040 different lunch options. So these are all the different ways I can choose 5 different lunches. So if we picked lunch, like maybe one of them was chicken sandwiches, once we use it, we can't use it the next day. But remember, part of this is going to be, it's going to be a different lunch each day. So that chicken sandwich could be the first day, could be the second day, could be the third day, could be the fourth day, could be the 5th day. So you could have the same 5 lunches and just order them in different ways as well. And those are all different ways of ordering this. So just to show you, in your calculator, we can do some of this. I was hoping I could get rid of these little ads here popping at the bottom. Okay. There we go. Something was in my way there. So if you notice here, it says math. So if we click on math, This is just tells me how to do fractions, cube roots. Then we have numbers, so looking at round numbers and things like that. This deals with complex numbers. And then we have PROB, so that is probability. And inside of here, you'll notice I have NPR, we have NCR, and I also have factorial. So if you want to do something like 8 factorial, I hit the wrong one. Let me go back and do that again. Well, let's say 9 factorial. So I hit that 9, I go to math. I go down to that, I hit enter. It gives me 9 factorial, and so it can calculate it for me. Now, if I want to do a permutation, I can do it like this, so the last one we had was the 12 factorial over the 7 factorial. And now I can do divide. So now I can do my 7 math. And we get that 95,040. So there's another way to do this. Because that problem was 12, and we're doing a permutation of 12, and we were choosing 5. You could also go in, you go to math, go to probability, and then we go to number 2 and hit enter. So depending how your calculator is set up, you might do this a little differently, but usually you need to put before it the 12. And then after you put that 5. So there's one other way you might see this, and I'll put it here in a second. And you see I'm getting that same number again. I'm getting that 95,040. So it could be look like this, or as a possibility, if you have like was it a TI-84? I'm trying to remember what it's called. There's a certain TI-84 that does this a little differently, acts like a TI-83 silver, the silver edition. You might actually have to put the 12 and then comma 5. So you might have to put it that way if it works a little differently. But that's another way that we can calculate these probabilities so that we don't have to keep doing this by hand. So moving on to combinations. So in combinations, what we say here is that order is going to matter for us now. Or not matter for us, I'm sorry. So in some cases, we choose, when choosing a set of objects from a larger set, we don't care about the order of the chosen objects. We only care which objects were chosen. For example, we may not care which lifeguard occupies which station. And it may not actually matter to us. And the last problem, certain lifeguards have to go to certain stations. We may not care which lifeguard goes to which station. We might only care which 3 lifeguards are chosen. So each distinct group of objects can be selected without regard to the order. Regard to order is called a combination. So if you go back to that lifeguard problem, let's say we choose, I'll say Sam, Tony, and Alex. Those are my 3 people get chosen for the lifeguard duty. In a permutation, we have different towers, right? Or different lifeguard stations. So, we got station 1, we got station 2, we got station 3. In a permutation, if Sam goes here, Tony goes here, and Alex goes here, that is a different group than if Tony goes here, Sam goes here, and Alex goes here. This is different. If this is Sam, but this is Alex, and this is Tony, that's a different group as well. So in a permutation, these are all different groups. When we talk about a combination, all we care about is that we just have these. So with a combination, Sam, Tony, Alex, that's one group, or Tony, Sam, Alex, etc. All these different combinations, all of these are the same group. So this is what we're talking about ordering a little bit, is that the order, if I change my orders here, I get different groups, but in combinations, they're all considered to be the same group. So when we do a combination, that is n CR, and we have n factorial, but now we divide by r factorial times r minus n factorial. So we're going to get slightly different numbers when we do this. So if we go back to that lifeguard problem, I should put lifeguard problem back here. If we do it as a combination, we had 12 lifeguards and we only choose 5 of them. And the permutation, we had 95,040. If we do this as a combination, you're going to get 12 factorial over, and my r was 5 factorial, and then n minus r we said was 7 factorial last time. We're actually going to end up with a much smaller number. And actually, I'm going to double check that because I'm not 100% sure I got that right. Okay, no, that's correct. So this means these are all the different just ways of I can choose 5 lifeguards. We're not looking at them being in different towers or anything like that. So this is where Sam, Alex, and Tony, Sam, and Alex, Sam, Tony, all of those belong to the same group. So we're going to get considerably smaller numbers in a combination. So as an example, at a certain event, 30 people attend and 5 will be chosen at random to receive a prize. So they're receiving a prize. The order in which they receive the prize doesn't matter because the prizes are all the same. So the order in which the people are chosen does not matter. If you're chosen first, it does not change your prize. So they're going to all be the same group. So we want to know how many different groups of 5 people can be chosen. Since order doesn't matter, we do a combination. So we would have 30 people are attending, and we're choosing just 5 of them to win a prize. So this will end up being, as a reminder, NCR is going to be n factorial, r factorial, n minus r factorial. So you can use this in your calculator and all the different factorials, but you'll have 30 factorial divided by 5 factorial, and then we'll have 30 minus 5 factorial. Okay. So you get something like this. So you know how to use the factorial buttons. So if you wanted to put this as all one problem, you could. I'm going to show you in a little bit here how I can do this with a combination function like we have for permutations. But what I get here is 142,506 ways 5 people can win. So remember, they're not 6 different ways 5, or not, different combinations. This is just ways 5 people can win. So it doesn't matter the order in which they won, that all counts as one group. So we'll go back to the calculator here. But I do have this in your handouts if you needed it to go and kind of look at another way of about how to look at your calculator and do this. So once again, if we want to do that last problem, we hit math, and we go over to probability, and then we do NCR. So that is going to be 30 people who are in attendance. 5 of them are going to win a prize. And that is how we get 142,506. And just to show you, if I'd done this as a permutation instead, remember permutations is going to mean that each group of 5 people gets chosen as a different group depending on the order they're chosen, then we get something significantly bigger. Here we're looking at 17,100,720. So there's a big difference between a combination and a permutation. We need to pay attention of whether ordering does matter or not. Okay, so a little bit more in going into order and matters. So when we change order of items in a group and do not create a new group, we're looking at a combination. For example, a club needs 3 members to represent a club, and they choose Ash, Max, and Casey. If we change the order of the members, we do not have a new group of representatives. Here, order doesn't matter. And this is where we do a combination. So we would have a combination. Like I said, I just need 3 representatives. It doesn't matter if it's Ash, Max, or Casey, or Max, Ash, or Casey, Ash, and Max, or Casey, Ash, and Max. All those orders do not matter. They're all one group. When we change the order of the items in the group and it creates a new group, we're looking at a permutation. So for example, instead of saying I just need 3 people to be my representatives, we say we need 3 people, but they need to be officers. So now 1 will be president, 1 will be secretary, 1 will be treasurer. And if we choose Ash, Max, Casey, and Max, again, respectively, that means that Ash would be the president. That would mean that the secretary, that would be Max. And that we're saying that the treasurer is going to be Casey. So here order matters, because if now I say, well, no, you know what? I think Max is going to be president, Casey's going to be treasurer, and Ash is going to be, or sorry, Casey's going to be secretary and Ash is going to be treasurer. That is a completely new group. So if the order of the member, if we change the order of members, they take on different roles and they create a new set of officers for us. So here order does matter, and that is always when we're going to do a permutation. So if an instructor must make a 3-question quiz on a unit and has 8 questions to choose from, does the order matter? So if I put my questions in different orders, does it actually make a different quiz, is really the question. So I'd say no, order does not matter. You'll see that your instructors will do this rather frequently, is that they'll take questions and they'll just reorder it and give you the same, everybody the same questions, but in different order. In this case, we would do a combination. So we would have 8 items to choose from for a combination, and we're choosing 3 for a test. So there would be 56 different tests that I can make. Or different quizzes. So admittedly, some of this could be a little subjective. So if you're a little confused on a homework question, you just make a combination or a permutation, you know, if like the one doesn't work. An English instructor is creating an assigned reading schedule for a syllabus. They need to assign 4 novels to read out of 9 approved novels. Does the order matter? In this case, yes, because the schedule will change. If you're going to read Pride and Prejudice, if you read it first or the second book or your third book or your fourth book, that is a different schedule that needs to be created. So yes, order matters. So the different orders of the books. So after I pick those 4 books, the different orders of the 4 books create different schedules. How many different schedules can be created? So in this case, we do a permutation because order does matter. So we would have, how many did I say? Oh, 9 approved novels. And I am going to choose 4 of them. So this is going to be 9, choose 4. In that case, we have 3,024 different possible schedules that can be created for the syllabus, depending on what books we pick and the order of those books. So we can use these counting principles to help us with some probabilities. So here we have a box of light bulb contains 8 good light bulbs and 2 burned out light bulbs. 4 light bulbs will be selected at random for a new lamp. What is the probability that all 4 bulbs are going to be good? So we're putting them into new lamps. It doesn't say the order on the lamps matters. Like I said, the order does not matter here. Just okay. So if order doesn't matter, we're talking about combinations here. So I need to figure out what is the probability that all 4 are good. So that means I need how many ways to get 4 good light bulbs. Out of ways to get 4 bulbs. So this is how we're looking at it. So there's different ways that I get 4 bulbs, but how many ways out of those are going to be ways to get good light bulbs? So if I just want ways to get 4 bulbs, what I'm looking at is that I have a total of 8 bulbs. Oh, sorry, 8 good bulbs and 2 bad bulbs. So I have a total of 10 bulbs altogether. I'm choosing 4 of them. So I'm going to do 10 choose 4. Which I have to calculate here. So we're going to have 10 choose 4. So there is 120 ways to just get 4 bulbs. Ways to get 4 good bulbs. This means I'm only choosing out of good bulbs. I don't want to choose bad bulbs out of this. So I have 8 good bulbs, and I'm choosing 4 of those. So there are 70 ways that I can choose 4 good bulbs out of 8 good bulbs. So what I have here, probability, all 4 are good. As I have 70 ways to get just 4 good light bulbs out of 120 ways to get light bulbs. So this is really just going to be 1 out of 3 or 0.33. So there's about a 33% chance that I would just get all good light bulbs. Okay. So this is going to cover a little bit of a bunch of things that we did here. It's kind of wrapping up our section. So our first question is, a committee of 8 people must choose a president, vice president, and a secretary. How many ways can this be done? So because we're choosing offices, the order in which I pick my people is going to matter, because if I change their order of the same 3 people, then they're going to have different positions and it's going to be a different group. So order matters. So if order matters here, that means that I'm looking at 8 possible people to commit to on the committee, and I'm choosing 3 of them. Oops. We're doing a permutation because order matters. So I need every way that I can put these people together in every kind of order. So we're going to get 336 different ways that this can be done. 2 of the committee members are Ellen and Jose. Assume that the assignments are made at random. What is the probability that Jose is president and Ellen is vice president? So this is a and probability. Ellen and Jose. So this is the probability that of Ellen being president times the probability that Jose is vice president. So Ellen has a 1 out of 8 chance, and Jose has a 1 out of 8 chance. Oops, it's times. I don't know why I keep forgetting the times on these ones. This is 1 out of 56. Oops, sorry, 1 out of 8, 1 out of 7, duh. I'll go back and do that in a second. Sorry, this little part here is messing with me. Jose. Ellen has a 1 out of 8 chance, but Jose has a 1 out of 7 chance, because once Ellen is president, once Ellen is vice president, then there's only one position, there's one less person that can take the position of president. Tight little space that I made here. So this is conditional. Because like I said, once Ellen takes a position, there's one less person to take the next position. And it doesn't matter if I switched it and it was Jose first and then Ellen first, that wouldn't matter either. What is the probability that either Ellen or Jose is president and the other is vice president? So this is Ellen is pres and Jose is VP, or the other option is it switched and Jose is president and Ellen is VP. So this is an or. So we already know one of these, the probability that Ellen is vice president and Jose is president is 1 out of 56. And this is an or event, so this is a plus. So the other option is this, is either that Jose is vice president and Ellen is president. And like we said here, it doesn't matter who's first, it's still 1 out of 56. So this is 1 out of 56 plus 1 out of 56. And this is going to be, is 1 out of 28. Yes. So in the end, this is going to be 1 out of 28. Here we have 8 students are applying for an internship at a local firm. 3 of them are selected for interviews. How many ways can this be done? So we're just selecting 3 for interviews, but we're not specifying like who's being interviewed first or anything like that. It doesn't seem to matter. So I'd say order does not matter. So we're looking at a combination. So we have 8 students and we're only selecting 3 of them. This is going to be 56 ways that we can end up picking 3 of these people to interview. So the next question, of the 4 students are from Middle George State University. What's the probability all 3 interviewed are from Middle George State University? See, these are 56 different ways that I can select 4 interviewees. Then we need how many ways? We can pick 3 from Middle Georgia State University. So we have 4 of the students are from Middle State Georgia University. We just need to pick 3 of them. And so that is 4. So the probability that all 4 of them are going to be from Middle Georgia State University would be, we have 4 ways to choose 3 of them from that university out of my 56 possible ways that I can choose. And that is going to be 1 out of 14.